Welcome to the next episode here of Dan on Dev, talking about why all AppSec products suck. Hopefully you've watched the first episode of this series. I do an overview there. You'll definitely want that overview before you dive into this one. Now if you're just looking at SAST products, static analysis, security testing products, then this is fine. And hopefully you already know a little bit about the overall categories. If not, go watch that first episode. It lays out the baseline of this conversation. But today we're going to be focusing on why all SAST products suck. Again, this is not about just being critical of the way SaaS products work. It's actually, again, as a reminder from the first episode, I'm looking at the idea that no one type of tool is going to solve your problem. The analogy I'm using here is if you were to be having to build a house and you can only pick one tool, what would you pick, and would you even be successful? Even if you could, I don't know what tool you would pick, but the chances of you being successful are very low. So you need to understand how each of the tools work, what they're good for, and that's what a lot of this is about. Today we're going to be taking on SAST products, the static application security testing, or static analysis security testing. There's the other ones, DAST, IAST, SCA, WAF, RASP, manual pen testing. Those are all different episodes where we're going to dive into each one of those, but you can get it all in the episodes to come, or the ones that have already been put out. So today we're going to be focusing on SAST. Now, a little bit of a 101 on what a SAST product does. What they actually do is it actually reads through the source code, which is amazing. It actually reads through the source code, looks through it, and can often identify errors that will lead to general bugs, and those bugs can also be the ones that are going to end up as security bugs. Some security issues generally are just a bug. A bug is a bug is a bug, but when it creates a security implication and not just like something that doesn't work, that's where it becomes a security issue. But it's ultimately a bug, and so you really want to get to the developers so they can fix it. So the really nice thing about SAST is it's looking at that, and you would think that's amazing. It's looking at the code. If it has basically the blueprints, well, of course it's going to be able to find the issues, right? Wrong. It is a difficult problem. You are basically creating a robot that is looking for these bugs in code that can be very difficult to interpret. On top of this, just general issue of difficulty, and we're going to talk about that a little bit more. These static analysis tools, these SaaS products, they need to understand the language. They understand, so the language, the coding language, not the human English, Chinese, whatever. I'm talking the software development language needs to be supported for you to be able to get good analysis. And there's a ton of programming languages. So depending on which languages, and this is part of what I talked about in the first episode, is you need to understand your own environment. You need to know how your products are being built, what languages, what the dev process is, the DevOps process for putting out releases. You need to understand all these things so that you can actually make a proper analysis of what tool is going to work. This is especially true for a SAST product because it needs to work well for the language that you're dealing with. Does it even support it? Okay, and then if it is on their checklist, let's say they have their little checklist of all the languages, and it's on that list, well, the next question is, how well does it support that particular language? I've seen a lot of these SaaS products out there. They will analyze some languages really well, and other ones, they're just trying to get more and more languages supported. Right? I'm air quoting here. They're getting more and more supported. You end up with a challenge for them because you can't go in extreme depth on every single language Well, you could in enough time and enough resources, but realistically, are they going in depth on a given language, or are they reaching for breadth of supported languages? Do they want as many languages that they can actually put on their little checklist as possible? But then that tends to mean they don't go very deep on each one. So this is a challenge. If you've got multiple languages and you say, oh, well, this one product over here goes really deep in the language that we use a lot. Let's say Java or something. It actually has really amazing support for Java. But then you have 25, 30% of your code that's in another language that really has very weak support or no support at all. Now you've got a problem because maybe one SaaS product won't actually do the job. You may need a couple different vendors brought in, depending on how critical certain languages are to your business and how well they're supported by one vendor or another. So this is a challenge for this type of tooling. And it's just, if you see that they have a massive list of languages, my guess is they're focusing on breadth and not on depth. And you can go test that theory by actually running demos and things like that. The next challenge that you have is that code is often more art than science. It is. There are a lot of ways to do things with software development. When you're writing code, you can do things a lot of ways. Sometimes you don't do things correctly, air quotes again here, but it will work, and maybe works perfectly fine. You're writing code that, so just think about what a SaaS vendor has to do. They have to write code that reads other code written by humans, in all these different programming languages. That is a difficult challenge. There is no easy path here. They have a very difficult job to write code that reads code and tries to interpret what a human is doing this code for, or how the machine would actually interpret it. This is a difficult challenge. So even a human reading things, there's times where I look at my old code and that you wrote, like there's a little picture here if you're watching the video. When you find code that you wrote when you were a beginner or even just a couple years ago, you will look at it and go like, what was I thinking? Why did I do it that way? But if you go to debug it, it works fine. Why change it? Sometimes people like to refactor, especially if another person comes in, they're going to look at your code and go, I don't like this, and they're going to want to rewrite it. Now you take in a software program, right? Somebody else's code, reading my code, trying to interpret, that could get very difficult. So it's a tough problem. The other challenge here is that you're generally using a lot of other third-party products, third-party code bases as a part of your software, right? Hardly anybody writes all the code completely from scratch, all by themselves, with just the base languages. You may find some like C++ developers that'll do that, but that's fairly rare these days in particular. So what you end up with is a situation where you've got all these third-party pieces, and some of them could be binaries, could be like DLLs, which you'd be using on Windows a lot, or libs, and if you're dealing with Linux or whatever, there's libraries, SO files, whatever. There's all these binary libraries that would get used, and you don't know what happens in them, right? Your code calls into them, and then they do their magic, and they give you back an answer. Well, a static analysis tool that has the situation, now all of a sudden, it's basically like trying to solve a jigsaw puzzle with a bunch of pieces missing. They don't actually have, or actually, the better example here, let's say you had a jigsaw puzzle, right? But that was your math test, right? That was like your final test in math. But there's pieces missing. So you go lay it all out, and there's a bunch of pieces missing with parts of the questions in there, and yet you're still supposed to come up with the correct answer. That is a monumental feat. And so because of that, there's a lot of guesswork. Sometimes they'll understand what library that was because it's in their like list of known libraries, so maybe they'll kind of support it. But it is a difficult problem. you really need the whole code for the static analysis tools to do their best job, the SAST tools to do their best. So what they end up doing is a lot of guessing, and also just a lot of like looking around to see what can they tell you from the code base that they see. And often this will end up resulting in a lot of false positives. That's where they tell you there's an issue when there's really not. That could include things like bad coding practices. They didn't see the filtering that was happening. So like they tell you you're not filtering inputs, but there was actually a library that was doing that for you, and they don't know what that library is doing because they don't know what the framework does. These kind of things cause issues, create a lot of false positives. Now, let's just jump over quickly about why SAST products rock. They actually are amazing. As I mentioned earlier, the task they're taking on is monumental. It is a very difficult challenge. But they're looking at the code, and so they can actually see issues as early in the process as any tool possible, because they're there where the developer is actually writing the code. They can actually see it and start addressing the issues. They can flag them early, right? They can also just, while they're looking at the code, they can look at the bad practices and identify those and make recommendations for how to do this better. And so the developers often can learn how to do things better. Again, hopefully they're not learning to flag, to suppress false positives, but whatever. No, really, it actually can get there very early. And then the other very key thing is that when there are security issues, they are able to report the exact lines of code involved in the issue, and that would create the bug or security issue, and that makes the time to fix dramatically faster because they're showing the developer exactly where to go look at their code to go fix it. That's amazing. Super advantage to the SAST users and the developers getting the SAST results. So that's our discussion here about why SAST products suck and why they're amazing, actually. But again, there is no silver bullet in cybersecurity. A layered solution is the only viable defense. You need to look at all the different products. We're going to be talking about DAST products next. That's a dynamic scanner that can run against the application. Again, we'll get into the details of that coming up. If you want to find out more from me, from Dan, check out our site, danondev.com. You can follow the YouTube channel, Dan on Dev, and happy to share as much as I can about application security, cybersecurity in general, software development, and leadership of software dev teams. We'll be covering all those categories, so keep watching.